Hi guys, we are Shapeshifters. For today, we are going to discuss about Polygon.
So, the objectives for today's lesson are: first, identify different kinds of polygon by their number of sides and angles. Second, determine if the shape is concave or convex. And lastly, solve problems involving sides and angles of a polygon. So, now let's... Really? A notification at a time like this? Fine, let's check it out together.
Hey Jill, do you understand our topic about polygons?
No, I don't understand the topic about polygons. What about you?
Me also. Come on, let's go ask Delvin about it. Hey Delvin,
Hello.
may I ask you a question?
Yes. Okay.
What is polygon?
I am currently understanding it in the image book. It is said here that a polygon is a plane figure formed by three or more segments such that each segment intersects exactly two others at one at each point, and no two segments with a common endpoint are collinear. The examples of polygons are triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, and the decagon. The following are some useful polygons, such as the stop sign, the do not enter sign, the yield sign, and the pedestrian sign. A polygon with congruent sides and congruent angles is a regular polygon. Now, let's get onto the topic of concave and convex.
Oh, so they are actually confused about polygons, huh? How about we discuss about concave and convex? Wouldn't that be fun? Come on, let's explore more about polygons.
We know that any clue shape formed by straight lines is called a polygon. That is actually the reason why the shapes on the board are considered as polygons. So, what are the differences between concave and convex? Concave, at least one interior angle measures more than 180 degrees or reflex angle. One or more vertices point inwards. At least one diagonal line lie outside the closed figure. When the sides are extended, they can enter inside and intersect any side of the polygon. How about convex? All interior angles are measured less than 180 degrees. The vertices point outwards. When the sides are extended, they do not enter the polygon. Next question. How do we determine whether a polygon is concave or convex? We can simply determine it by extending its exterior lines to form diagonal lines. If the line intersects inside the polygon, it is a concave polygon. Meanwhile, if the lines do not enter the polygon, it is a convex polygon. That is all for convex and concave. How about we make some twist? Solving problems involving sides and angles of a polygon. Oh wait, I gotta go. Let Ray help you with that topic.
Now, let's move on to our next topic, which is about interior angles of a polygon. In this table, we have the triangle as our first regular polygon. It has 3 sides, 0 diagonals, and 1 triangle. When we get the sum of the interior angles of a triangle, it should always result in 180 degrees. As for the value of each interior angle, we have 60 degrees because we divided 180 degrees by the number of sides, which is 3. Second, we have the quadrilateral. It has 4 sides, 1 diagonal, and 2 triangles. The reason why we got 2 triangles is because if we draw a diagonal on a quadrilateral, it will result in 2 triangles. To get the sum of interior angles, we simply multiply 180 by the number of triangles, which resulted in 360. As for each interior angle, we have 90 degrees as our value because we divided 360 degrees by the number of sides, which is 4. The same goes for any other polygon. As you can see, there is some sort of pattern given. Let's use the pentagon as an example. A pentagon has 5 sides, and to get the number of diagonals, we'll just get the difference of 5 and 3 to get the result of 2 diagonals. The number of triangles is missing. Simply subtract 2 by 5 and there you have it, 3 triangles in a pentagon. Multiply the number of triangles by 180 to get the sum of interior angles and divide the result by the number of sides to get each interior angle. In the first example, can you try to solve the following? A regular hexagon has 6 sides. How do we get the number of diagonals? That's right. We will subtract 3 from 6 to get the result of 3 diagonals. How about the number of triangles? Correct. Subtract 2 from 6 and we will be left with 4 triangles. The sum interior of a hexagon can be solved by multiplying 180 by the number of triangles, which will result in 720. Lastly, divide 720 by the number of sides, which is 6, to get each interior of a hexagon. Now, let's move on to our next topic, which is about exterior angles of a polygon. An exterior angle is formed by extending one side of the polygon. And as you can see in the figure, the exterior and interior angle of the polygon forms a linear pair, which means that they are supplementary angles. If you add the exterior and interior angles, you will get the result of 180 degrees. We have a regular octagon as our example. Knowing that it has 8 sides, how do we get the following? To get the sum interior of an octagon, simply use this formula. Replace n with 8 and begin solving. Now that we have 1080 degrees as our sum interior, let's divide it by 8 to get each interior angle. Nice! We can now solve for the exterior angles. The sum exterior of an octagon is 360. And to get each exterior, subtract 135 from 180. Just like I said before, we subtracted each interior angle by 180 to get each exterior, because interior and exterior angles are supplementary angles. Did you notice that the sum of exterior angles is always equal to 360 degrees? This is because extending each side forms exterior angles, which sum to a full circle around the point that measures 360 degrees. Here are the following formulas in a regular polygon with n sides. Can you try to solve for the x of the following regular polygons? What is the x in the first example? Correct. The x in the first figure is 25, and this is the solution. How about the x in the second figure? That's right. The x in the second figure is 7. We can check if our answer is correct by replacing x with the number 7.
That is all for our discussion about polygons. What are your takeaways? Comment it down below. Again, we are Shapeshifters. Subscribe, like, and click the notification button for more episodes. Have a nice day!